Section 1.7 is all about functions, what they are, how to talk about them, how to identify if something is a function. So let's get to it. First, let's define what a function is. A function is a relationship where each input only has one matching output. So you might be asking, what are these words input and output? An input is basically just your x value, which we'll also refer to as the independent variable. The output is basically just your y value, which we also refer to as the dependent variable. The way you determine whether something's an independent or a dependent variable is whether one depends on the other. So for example, if it's 90 degrees outside, the temperature in your car is going to go up. So the temperature outside will determine what the temperature inside your car will be. So the independent variable would be the outside temperature. The dependent variable would be the temperature in your car because it depends on what the temperature outside is. Another thing that we talk about when we're talking about functions is the domain and the range. The domain is basically just a list of all the x values or your inputs. And the range is a list of all the y values, which are your outputs. You'll see in the following examples, you'll be asked to list the domain and the range of certain functions. Often you're asked to check to see if a relation is a function. A relation is just the relationship between an x value and a y value, or an independent variable with a dependent variable, or even an input with an output. So, like I said, a lot of times you'll be given relations in different forms and asked, are they representing functions as well? You can decide if something's a function based from a table or a set of points. So first, look at all of the x values that you're given. If any of the x values are repeated, then the relation is not a function. It's still a relation, just not a function. If all of your x values match up to exactly one y value, then it would be a function. Because remember, the definition of a function was a relationship where each input only has one output, one and only one. So again, if any of the x values repeat, that's going against the definition of a function, and therefore it is not a function. If you're given a graph, it's really easy. All you have to do is look at the graph and run what is called a vertical line test. During the vertical line test, what you're going to do is run an imaginary line across your graph. If the vertical line touches the graph in more than one spot at a time, the relationship shown by the graph is not a function, which means that x values would have been repeated. You would have had two or more ordered pairs that would have the same x value going to two different y values. If the vertical line only touches the graph in one point at a time, then the relationship represented by the graph is a function, and you'll know that it passed the vertical line test and is a function. Example number 1, the input-output table shows the amount of money Miguel earns at his job for several numbers of hours. Identify the domain and the range of the function. So remember, input is representing your x values. In this case, it's representing hours. And the output represents your y values, which in this case represents dollars. So knowing that domain is the list of all x values or your inputs, and range is a list of all outputs or your y values, let's list them. So the domain would be the numbers 2, 5, 7, and 8, our input numbers. Notice that I used braces around this set of numbers. Whenever you talk about a set of numbers, you want to use the braces around that set of numbers. Next, for the range, we have 14, 35, 49, and 56. Those were all of our output numbers. And again, I used the braces around it because I was talking about a set of numbers. Example number 2, tell whether the pairing is a function. So when we look at part A, we have a set of inputs and a set of outputs. Our inputs are 2, 4, 6, and 8, and our outputs are 0, 3, and 5. And so remember, what we want to look at is, do we have any repeated x values? If it helps, go ahead and list the ordered pairs. So it says we have an input of 2 matched up with an output of 0. We have an input of 4 matched up with an output of 3. An input of 6 matched up with an output of 3, and an input of 8 matched up with an output of 5. So when I look at all of my x values, what I'm looking to see is, are any of them repeated? If you see here, we have 2, 4, 6, and 8. Now you might be concerned that we have repeated y values, but if you look back at the definition of a function, nothing is stated about y values not being able to be repeated. So in this case, this would represent a function. Moving on to part B, this time our inputs and outputs are given to us in table form. So if you see here, we have inputs of 1, 2, 2, and 4, and 2, 3, 4, and 6 for our outputs. If it helps you, not that it's required, but if it helps, go ahead and list these ordered pairs. So I have an input of 1 and an output of 2, an input of 2 and an output of 3, an input of 2 and an output of 4, and then an input of 4 and an output of 6. So again, what we're concerned with is if we have any x values repeating. And if you look here, the 2's repeat twice. So in this case, this would not be representative of a function. Example 3, the domain of a function y equals x plus 4 is 0, 2, 3, 6, and 7. Make a table for the function and then identify the range. So here I've set up the table for you. In your homework, you'll have to set up the table yourself. So first it says the domain is 0, 2, 3, 6, and 7. So I'm going to put that up here. 0, 2, 3, 6, and 7. And I'm just going to label this row as my x values, my inputs. My outputs would be the y values, because if you look at the equation, it was y equals x plus 4. So I know my inputs are going to be represented by x's and my outputs are going to be represented by y's. So I have y equals, and I'll find my y values by taking the inputs of x plus 4. So if my input is 0, and I'm supposed to add 4 to it, I'll get 4. 0 plus 4 is 4. If my input is 2, and I'm supposed to add 4 to it, 2 plus 4 is 6. So I have an output of 6. I have an input of 3. 3 plus 4 is 7. Input of 6. 6 plus 4 is 10. And an input of 7. 7 plus 4 is 11. So here again, make sure you're doing the whole problem. It also said to identify the range. So we're looking for just the y values, our outputs. So again, this is going to be a set of numbers, so we'll use the braces and put commas in between each of our numbers. So we have 4, 6, 7, 10, and 11, and then close the braces. Our next problem, example 4, wants us to write a rule for the function. So you can see here our table is given to us. Our inputs are 1, 2, 4, 7, and 9, and our outputs are 0, 1, 3, 6, and 8. So it's like we put our inputs into some kind of function, and we got these as outputs. So if I look at my input of 1, when I put 1 into our function, I got 0. When I put 2 into our function, I got 1. When I put 4 into the function, I got 3. 7 into the function, I got 6. And when I put 9 into the function, I got 8. So if you look here, it's always 1 less. I took 1, I subtracted 1, I got 0. 2 minus 1 is 1. 4 minus 1 is 3. 7 minus 1 is 6. 9 minus 1 is 8. So letting x represent our input and y represent our output, we got our y, the outputs, by taking our inputs x and subtracting 1. So when I ask for a rule of a function, really what it's just asking for is an equation that represents what's happening in our input and output table. Example number 5, at a community center, art lessons are offered at night. The fee is $12 per lesson. You plan to attend up to 5 lessons. So we have a list of things that we need to do for this problem. First, they want us to write a function rule. So remember, that's just like an equation. They want us to identify what the independent variable is and the dependent variable is. And then finally, we'll list our domain and our range. I like to start with defining the independent and dependent variables first. When I look back at the problem, it says I'm paying $12 per lesson, and I plan to attend up to 5 lessons. So therefore, the number of lessons that I take will determine the amount of money that I'm charged. So the amount of money depends on the number of lessons that I take. So therefore, my dependent variable, which I'm going to define as y, would represent the total cost that I am going to be paying for these art lessons. That means x, that I'm going to use for my independent variable, would represent the number of lessons that I end up taking. So if I look back at my problem again, it says the fee is $12 per lesson. If you think back to our previous sections, per means to multiply. So I would figure out what the cost would be, y, by taking the $12, and remember per means to multiply, so $12 times x, the number of lessons. So remember, we're planning on taking up to 5 lessons. So our domain would end up being 0. We could take 0 lessons. We could take 1 lesson, 2 lessons, 3 lessons, 4 lessons, or 5 lessons. By putting that into our function rule now, I'm just going to take each of my inputs, multiply by 12, and give us our outputs. So 0 times 12 is 0. 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48. And 5 times 12 is 60. So our outputs would have been 0, 12, 24, 36, 48, and 60. Example number 6 has us using the vertical line test. As you can see here, we're given 4 graphs and we're asked to tell whether the pairing is a function. So all we're going to do is take vertical lines and pass them through the graph and see if the vertical line is touching the graph in more than one spot. And as you can see here in part A, this vertical line, if I were to draw it right here, would pass through the graph in 2 different spots. If I drew a vertical line here, it passed through the graph in 2 different spots. So that means that I would have an x value matched up to some y value here, and the same x value matched up to a different y value there. So therefore, that is not the definition of a function. So this represents not a function. Part B, if I took vertical lines and passed them through each part of the graph, you can see that each vertical line would only pass through the graph in one spot. So part B would be a function. If you look at part C and we take vertical lines, passing it through, each vertical line would only hit the graph in one spot. So part C would also represent a function. And finally, if I pass vertical lines through the circle, which is part D, you can see we have a bunch of different vertical lines that if I drew in here, they would pass through the graph in more than one spot. So therefore, a circle is not a function. So that is the end of this lesson. Make sure you write down everything about how to tell when something's a function. Make sure you write down what it means to use the vertical line test, and make sure you come to class tomorrow with all of your questions so that we can clear those up before we move on.